All right, so this is the test 3 review. So for number 1, if you just look at your list, make sure that you have printed out the review and make sure that you've actually taken some time to look over it, because we're going to kind of quickly go over a lot of these things. So for number 1, to find the mean, there are 12 answers, right, or 12 numbers, so you would find the sum divided by 12. Okay. If you add those up on a calculator, you're going to get 300 divided by 12, which is 25. But if you read the problem carefully, it does mention that these are all in thousands of dollars. So the annual salaries is not $25, right? It's $25,000. Okay. The median, if you look at that list, you will look for the middle. Okay, so let me show you the list real quick so that I don't have to write them all down. So notice there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's going to be 2 tied for the middle. So 1, 2, 3, 4, 5, 6, and 7 are both tied for the middle. So since they're both 21, if you have 2 tied for the middle, you take the average of those 2. Not entirely necessary since we have the same value for both of those, but if you had different values, you would find the average of the 2. Okay, so 21,000 is the median. The mode, remember, is just the most frequent. And it looks like the most frequent is, again, 21,000. Okay, and then for the range, it's just the high minus the low. So the range is going to be 40 minus 18, or 22,000. Okay. And number 2, I ask you to be able to discuss when mean, median, and mode are more appropriate predictors of future data. Okay, so I'm just going to say, look at your notes / the lecture videos for this section. But basically, we talked about how sometimes if we have high or low numbers or outliers, that can really affect the mean. I gave you an example of Michael Jordan responding to the salary amounts for geology majors, okay, and he threw it all off. Well, if they would have used median or mode, it would not have been so detrimental for him to have responded, okay, and frankly for them to not have checked their data. So median and mode are less open for issues if you have an outlier, okay. But there's different situations when it's more appropriate to use one or the other, so make sure you look back for that. All right, for 3, I am going to list all the numbers because I really need to do something with them. So remember, if you had to do a dot plot of your own on the test, doing the dot plot first is actually really useful because then you can just list the numbers in order kind of quickly because they're already in order on the number line. So I'm going to make sure I have 17. Okay, and I do. Okay, so let's just go about finding some of these values. So first I want to find the middle one. So that's going to be, if there's 17 numbers, that's going to be the one square in the middle. So you can find the middle by doing this. Okay, like if you're finding that you're not counting them correctly, you can just kind of squeeze in on the middle in that way. But it's going to be the one in the 9th spot. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is known as the median. But when we get to the box plot for this one, that's going to be the Q2. I don't know why I wrote Q1. Okay, but that's the Q2. So in 3A, I said what is significant about the number 77? It is the median or the Q2. Okay, what numbers fall in the first quartile? So to do that, I actually need to figure out where the first quartile is. Okay, remember, when you have one number for the median, that number doesn't go in either half. If you have 2, you split them. One goes to the left, one goes to the right. So we have 8 values. So we need the value that is in between these 2. Okay, we have 2 tied for the middle. So Q1 is going to be 73.5. That's what's right in the middle between 73 and 74. And same thing over here. We're going to want to go square in the middle of those 2 that are tied for the middle over here. Okay, so when it asks how many numbers, what numbers would fall in the first quartile, it's anything less than this. So it is 58, 66, 67, and 73. In the second quartile would be anything all the way up to the 77. Notice 77 is not going to be in any of the sections in this case, okay, because it's kind of the single middle. In D, in the next section, it would be everything from 84, and you would stop, that should be 88, sorry. Stop when you get to 91.5. And then in the final section, you have everything from 92 on. So notice there are 17 values, and other than the one we kind of didn't put in any section, there are 4 values in each quartile. Okay, so notice if you divided 17 by 4, you get about 4. Okay, you get an extra one, but you get about 4. So each quartile contains 25% of the data. That's important that you know that. Okay, so for 4A, I kind of already did all the work here, right? The min is 58. Q1 was 73.5. Q2 is 77, Q3 is 91.5, and then the max is 100. These are the 5 significant values when you go to make your plot. So here's how I'm going to want that to look. I might want you to do a number line, like a scaled number line on the test, so make sure you know how to do that. And then I would want you to mark not only all these values, but you're going to tell me what they are too. This is 91.5. This is 73.5. Notice it works with the number line up here, right? And then this is the min. This is the Q1, the Q2, the Q3, and the max. Okay, so make sure you can go from scratch. Make sure you can draw a scaled number line and then put a box and whiskers kind of above the number line. You had a homework assignment similar to that. Okay, so I kind of already did B, right? Well, I guess not. I didn't do the range, right? So for the range, you would do the high minus the low, right? So 100 minus 58, which is 42. And then for part C, you need to find the inner quartile range. Remember back when we looked at this in the other video lecture, we called that the IQR. The IQR is always the end of the second box minus the beginning of the first box, so Q3 minus Q1. So in this case, that's going to be 91.5 minus 73.5. So that is going to give us 18. So the question of outliers is anything 1.5 times this outside of our boxes. Okay, so that would mean anything where we have Q1 minus 1.5 times the IQR, or anything where we take Q3 and add 1.5 times the IQR. Okay, so let's plug in what we know to be these values, right? So Q1 is 73.5 minus 1.5 times 18. That gives us 46.5. Here we'll have 91.5 plus 1.5 times 18, and we'll get 118.5. Okay, so notice anything outside of these, so anything less than the 46.5 or more than the 118.5, outside of these would be outliers. So if I asked you in this example if there were any outliers, you'd have to say no, right? There was no scores that were under 46.5 and none that were above 118.5. Okay, number 6, draw a triangle which is obviously isosceles and acute, but not equilateral. Okay, remember the definition of isosceles. I counted off just a little bit on a lot of your glossaries because you didn't have the right definition of isosceles. Isosceles actually means at least 2 sides congruent. Okay, so equilateral triangles are actually also isosceles. So we want to show that the triangle is isosceles but not equilateral. So you can do that with numbers. You can say, okay, I want these 2 sides to be the same, but then this one's different. Okay, you can also do that with symbols. You can do one or the other. Okay, you can do symbols. This shows that, hey, those are the same length, but this one is a different length. Okay, so you can either do it with numbers or with symbols. Okay, so notice now that I've shown half of this. I've shown isosceles, but not equilateral. Okay, so I'll go ahead and say check mark there. What I have not shown yet is that it's acute. Okay, so to show it's acute, you need to make sure that the angles are, that they follow the format for a triangle, which means they have to add up to 180, but also that we have acute angles. So what if I said these two were 55? Okay, by the way, the base angles in an isosceles triangle do have to be the same as each other. Okay, so notice that's 110, which puts this one at 70. Okay, notice that all three are less, right? So now we've shown acute, and we can check it off. Okay, notice we need not only the measurements of the outside to show isosceles, but we actually need the angle measurements to show acute. Okay, so when I say to show something, I actually mean with numbers or with symbols or something like that. All right, so number 7. We haven't done problems exactly like this, but if you remember two facts, okay, if you remember that the measurement from here to here is 180, and if you remember that the measurement from here all the way around is 360, then you actually should be able to do these problems anyway. Okay, so let's look at part A. So if we're going to go 225, we're going to actually have to go past 80, right? So from here to here is 180, right? But we want to go past that, okay? So we need to go a little bit further, right? But we don't want to go 90 more, right? 90 more would leave us at 270. So we actually want to go right in the middle. And then we just list this as 225 degrees. Okay, notice the arrows are kind of important. The arrows show like what full am I counting as the angle. So this would be part A. So now let's look at 330. Okay, notice a different way to look at that is we're not going quite all the way around, right? So how shy are we getting to 360? We are 30 degrees shy. So you can kind of draw that. Mine's not perfectly to scale, but if this is 30, then you can clearly draw that this is 330. So even though we didn't do problems just like that, we did the foundations that you would need to be able to do a problem like this. Okay. All right, so let's look at 8A. Okay, two lines in a plane which do not intersect each other must be parallel. That is true. Okay, that is the definition of parallel. Definition of parallel is two lines in a plane that don't intersect each other. Okay, so if I ask you to give a reason and it's true, you can give just a brief little explanation. Okay, if two lines lie in the same plane, then the two lines must intersect each other. That is false. Okay, C part A, right? Parallel lines don't intersect each other. So you can have lines that don't intersect each other. Okay, so you could either give an explanation like that, or with part C, okay, a parallelogram is always a rectangle. That is not true. Okay, and remember we talked about this before, but you can provide one counterexample that shows why something's false. The counterexample needs to be detailed though. We would need to show a parallelogram that was not a rectangle, okay, and clearly not a rectangle, not just because we say so. So you'd need to do maybe with these symbols. So remember those two triangles mean, hey, those lines are parallel. And then this double set of triangles means these lines are also parallel. Okay, so notice I've shown it's a parallelogram, right? Because the definition of parallelogram is a four-sided figure that has two sets of parallel sides. Okay, but now I need to show that it is not a rectangle, so I can do that pretty easily. Maybe I can go down here and just say, hey, that's 110 degrees. Okay, notice this is not a right angle, which disqualifies it as a rectangle. Okay, so notice this picture is a parallelogram that is clearly not a rectangle. That's why we've shown that that's false, right? A parallelogram doesn't have to be a rectangle. Okay, so you are going to probably see some true-false questions on the test. Okay, they might test your geometry knowledge. They might test some of your other skills as well. So make sure you read them and be prepared to give a reason for why you're saying true or false. You might see some fill-in-the-blank questions as well. So a triangle that has at least two congruent sides is called, we already actually talked about this one today, so it's called isosceles. B, an angle whose measure is between 0 and 90 is called acute. Okay, for C, I'm going to show you what I was looking for, but then I'm going to tell you some different answers that I would expect, or that I would accept, I mean. When two lines intersect, the angles that formed that are next to each other. So, sometimes if you're having trouble visualizing it, draw a picture. So, if you draw two intersecting lines and you talk about the angles next to each other, Okay, we could either call this adjacent, which is actually what I'm looking for. Adjacent means right next to each other. But another thing you could have said, just because they form a line under them, is you could say they're supplementary. Or something we didn't actually talk about in class, but you might have learned in another one. You could also say they are a linear pair. Okay, I would have accepted any of these answers. Okay, so just because you give me the answer that I wasn't really what I was wanting was adjacent angles, but if you give me an answer that's correct, it's just maybe not what I was thinking of, I'm not going to penalize you for that. All right, so number 10. So I'm going to attempt to redraw this pentagon. It's not going to be the best pentagon in the world. All right, so here's a pentagon, and I asked you to show me an interior angle and an exterior angle. So here's an exterior angle. It's just one. There's lots, right? An exterior angle is formed when you draw a line out, extend a side out on the shape, and then just any of these would be interior. Okay, any of the 5 you wanted to pick that were on the inside would be considered interior. Okay, number 11, use proper geometric language to define the term trapezoid. Okay, so what I mean by that is it needs to be correct terminology. Okay, so a trapezoid is a quadrilateral with exactly one, the word exactly is important here, exactly one pair of parallel sides. If you don't say exactly one, then you could say a parallelogram has one pair of parallel sides. It actually has 2, but it also has 1, right? So you have to be really, again, use exact terminology, use proper terminology, but it's a quadrilateral with exactly one pair of parallel sides. That's what a trapezoid is. All right, number 12. The next 2 are Pythagorean theorem problems. Okay, so we have a building that is 17 foot tall. We have a ladder coming off of said building that is 20 feet. And what I've asked you is, what's this measurement? What's the measurement from the base of the building to the base of the ladder? So we have a squared plus b squared equals c squared anytime we encounter a right triangle. Okay, remember c is always the hypotenuse. So this would be 17 squared plus b squared equals 20 squared. So this would be 284 plus b squared equals 400. And then if you subtract the 284 over, sorry, it's not 284, it's 289. Just kidding. But subtract the 289 over and you'll get 111. And then we don't particularly want b squared, right? We actually want b. So b would be the square root of 111, or right around 10.5 feet. I think I told you to round to the nearest tenth on that one. Okay, so I know it's a little out of order, but I think I forgot to do number 5. Okay, I don't think I actually did forget. So I do want to mention number 5, so let's kind of switch trains of thought and we'll come back to number 13. But let's look at number 5. Okay, when you do a stem and leaf plot, make sure that you label the columns as actually stems and leaves. Okay, and so then you can just kind of read off the numbers. There was a 58. In a stem and leaf plot, the leaf should always be 1 digit. There was a 66 and a 67. You can separate those with commas if you wish or not. We had a 73, a 74, a 75, 2 76s, and a 77. I'm going to squeeze it in here. We had an 84, 87, and 88. We had a 91, 2, 4, and 6. And then last but not least, we had 100, and you just put a 0 there. Okay, so I know that's super squeezed in there, but I think stem and leaf plots we understood pretty well. You can also make sure you didn't forget any. by counting them, there were supposed to be 17 values for number 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so just make sure you label the stem and leaf, okay, and make sure also that if you happen to have skipped any, like for instance, if there wouldn't have been any 60s, then we still would have put the 6, but we would have put nothing over here. All right, so sorry about that. I was just thinking, where'd the stem and leaf plot go, and then I remembered. All right, so let's look at number 13. Okay, number 13 is a Pythagorean theorem problem also. Okay, you just have to kind of get away from the fact that maybe we don't have all the information we need. Okay, so on the one hand, we could do Pythagorean theorem and find out this length, but notice we don't really need that length. Okay, that's not what we're asked to find. We're asked to find this length. So we have to actually look at the triangle as a whole. Okay, so keep in mind, we actually don't know what this base is. It's 45 plus something. We just don't know what that something is. Okay, so let's just pretend that the base is unknown, because essentially it is. We know part of it, but we definitely don't know it all. So I'm going to pull out kind of the relevant information. Okay, I know that this is 92 feet, this is 30 feet. So let's figure this out. So 30 squared, plus b squared equals 92 squared. So this is going to give us 900 plus b squared equals 8464. And then if we subtract 900 from both sides, we're going to get 7564. Okay, but I don't really want b squared, right? I want the square root of that. So b is going to be the square root of 7564, which doesn't come out pleasantly, but it comes out to be about 86.97. Okay, it's important to note that that's not our answer, right? This is 86.97 feet, but the question asks you what x is. Okay, so you have to go back to your picture. Okay, notice this is 86.97, so all we'd have to do is subtract off 45 and we would have x. So in the end, always make sure you're answering the question that's asked. 86.97 minus 45 would be right around 41.97 feet. Okay, so for the next couple problems, I'm going to do it on the review itself because there's no way I'm going to try to recreate these pictures. It'll be sloppy and I don't want to do it. Okay, so let's go ahead and label what we know. DEA is 93 degrees. FGH is 101 degrees. GIC is 148 degrees. GHI is 18 degrees. GFB is 116 degrees, and then finally FBE is 101 degrees. So there are easier relationships to guess on this one or to figure out, and then there are more difficult ones. So I like to start with the vertical angles first. If that angle is 93, then so is the one across from it. But then we also have the relationship from here to here of being 180. So that means this one's 87, and so is this. Okay. And so we can do something similar here, right? If this is 148, from here to here would also be 180, so this would have to be 32. If you add those up, you get 50, right? And triangles, interior angles have to be 180. That means this has to be 130. Okay, and at this point you might notice you're kind of at maybe a stopping point. Okay, let's go ahead and fill in the ones that we know. This is 32 degrees. Okay, we got BEC to be 93 degrees. And HGI is 32 degrees. Did I do the wrong one? HGI, oh no, HGI is 130. Okay, so now we have to use a couple of relationships that might not seem as obvious. Okay, one is the fact that from here all the way around, we talked about that on our earlier question, is 360. Okay, so if you add 101 and 230 together, you get 231. Okay, and if you subtract that away from 160, you get this is 129 degrees. Okay, so again, this circle that I'm pointing at right here has to be 360 degrees. And then the last one's a little tough. Okay, we have to remember that this is a hexagon, and the hexagon interior angles have a pattern. The interior angles add up to, remember the formula, right, that we did on our glossary. It's sides minus 2 times 180. So that's 720 degrees. Okay, so if you add up all of those, so let's go ahead and do that with our calculator. So we've got 93. We're adding up the interior angles. We've got 148. We've got 129. We've got 116. We've got 101. Notice the only one we're leaving out is right here. Okay, so if we take, to get this, we would do 720 minus 587. Okay, so we'd get 133, and then that completes our picture. So this would be 133 degrees. So notice, you not only had to know that a circle measures 360 degrees, but you also had to remember this rule for hexagons. Okay. Now the one on the test, I might give you one that has a different shape. So you need to remember triangles are 180. Rectangles or quadrilaterals of any kind actually are 360. Okay, pentagons are 540, and so on and so forth. Okay, so let's also do this one, just written on the paper itself. Angle 3 is 140. So you can go for a while on vertical angles and supplementary angles. So notice this is going to have to be 140 because these are vertical, and then these have to add up to 180 with the 140. So this is going to be 30 degrees because it's vertical with this one. And then this is going to be 150 and 150. And then notice you have a triangle in the middle, so this is 70 degrees. That's going to have to be 180 altogether, so this is definitely not to scale, but this is going to be 110. Which makes these 70, right, so that they can add up to 180 with 110. And it's here where you might have to take a pause and be like, okay, now what do I do? Okay, well, what you do is you're going to use some of your angle relationships. Okay, so I don't care which transversal you use, but here is the parallel lines, and you just need to pick a transversal. So let's just say I picked this one. In other words, I'm going to not focus on this line. I'm just going to focus on the ones that I just kind of colored in. Okay, so if I do that, notice if I focus here and here, this is like the top left angle. Okay, so if I look for the top left angle down here, that means these have to be the same. Those are called corresponding angles. So if that's 30, this is 30, which makes these 150. And then we got the triangle relationship again, right? This is 140, so this would be 40, 40. And then these would have to be 180 with the 40. Okay, so it's like once you get one of these, you can move along pretty fast and get these. Okay, but we had to use one of our relationship pairs. Now notice I used the fact that we had corresponding angles, but there are plenty of other angle pairs you need to know well. Okay, we had corresponding angles. You need to know how to find those. We had alternate interior angles. You need to know those as well. Alternate exterior angles. Remember, all three of those that I just mentioned are congruent as long as the lines are parallel. And then the last pair that we talked about was consecutive interior, and those are stacked on top of each other on the interior, and they're supplementary. They're not equal to 180. So you'll definitely want to look back at your homework over that topic for sure. All right, last page. So just make sure you show me a little bit of work. Okay, so for this, you're going to have obviously a rectangle plus a triangle. So 5 times 7 is 35 centimeters squared. If you can't seem to fit it, you can do something like this. Remember, the area of a triangle is 1/2 base times height. Okay, so this is going to be 1/2 4 times 5, or 10 centimeters squared. So the total between the two, if you add them up, is 45 centimeters squared. Okay, remember with area, it's always units squared. Okay, for the next one, you have to work just a little bit harder to find out the measurements. Okay, so notice we still have a rectangle here. 8 by 9 is 72 centimeters squared. But then when we get to this triangle, we just need to fill in what the height and the base are. Notice if this is 20, okay, and this is 8, then that means this must be 12. If this is 9 and this is 4, this must be 5. Okay, so again, if we run out of room, we can do something like this. We have 1/2 base times height. So it's 1/2 12 times 5, or 30 centimeters squared. And so the total would just equal what you get when you add those up. Okay, so the total would be 102 centimeters squared. Okay, for the shaded ones, notice that we would want to take the big rectangle and its area minus 3 of the small rectangles. So that's not too bad, right? So we would just do 10 by 8. I know it's really hard to see these numbers. That's why you need to have your own review out. Minus 3 times the 4 by 2 rectangles. So that would be 80 minus 24. Okay. So in the end, you're going to get 56 centimeters squared. So here, notice we have triangle minus rectangle. So the triangle would be 1/2 base times height minus the 3 by 5 rectangle. Okay, so you're going to get 60 minus 15, which is 45 centimeters squared. Now, in the example problems I gave you, I tended to focus on rectangles and triangles. Okay, but remember, any shape is up for grabs. Well, any shape that we talked about. So you need to make sure you know trapezoids, and you need to make sure that you know circles as well. Okay, because those could be kind of added in there. Okay, so let's look at these angles. Now remember, when we measured these with protractors, okay, we made sure to extend the line out so that we could really read it. Okay, so you center the angle here, line up the base as perfectly as you can. Okay, so this is right at 20 degrees. Okay, by the way, let's put this back. Notice I wouldn't read the top numbers because I didn't start at 180, right? I started at 0 and read this way. Okay, as opposed to this angle, which is clearly obtuse, right? So we're definitely expecting something higher than 90. In fact, we're expecting something pretty large, right? Pretty close to 180. So if you line this up, again, it's a little harder to tell actually with this one because the vertex is a little iffy. So if you line it up and you look to see where it hits, I would say it hits about 172 degrees. Okay, so make sure you review how to measure with protractor. And then for the final question on the review, make sure that you know these things. Okay, I'm not going to give you this on the test. You're going to need to know most of these measurements and kind of how they work. Okay. All right, so let's look at tablespoons to cups first off. So I'm going to move this away and do this on the paper because I think we'll have more room that way. So this is number 18. So we are trying to go from tablespoons to cups. Okay, notice we're going from smaller to bigger. That means we divide. So look on your sheet and notice there are 16 tablespoons in a cup. So we are going to divide by 16. And if you divide by 16, you get 4. Okay, I'd want to see this work right here. I'd want to know that you knew how to do that, that you didn't just happen upon the answer. Part B, I'm asking you to change miles into yards. Okay, if you look at your page though, I didn't really talk about how many yards there are in a mile. Okay, so when that happens, you might need to do this in stages. I did, however, talk about how many feet were in a mile. Okay, and then we should know how many feet are in a yard. Okay, so maybe I can kind of do this in stages. So I'm going from bigger measurement to smaller, right? So a mile is 5,280 feet. So if you multiply that out, you're going to get 10,560. Okay, that's how many feet it is. But now we need to go from a smaller measurement to a bigger measurement. So now we're actually going to divide. So we would divide by 3. And when you divide by 3, you get 3,520 yards. Okay, so before we do the next problem, I want to remind you of how this works, right? You have the base, okay, and you have deca, hecto, and kilo to the left of the decimal place. You have deci, centa, and milli to the right of the decimal place, okay? And remember, the base units are meters for length, grams for weight, and liters for volume. Okay, so this is going to be helpful when you get to problems like this, because then you just need to count how many decimal places you're going. So for part C, I want to go, I want to talk about 20,000 decigrams, and how many hectograms is that going to be? Okay, so I'm going from deca to hecta, so I'm going 1, 2, 3 spots. Okay, then you have to ask yourself, am I going from a smaller measurement to a bigger, or vice versa? Notice deca is definitely smaller, right? It's to the right of the decimal place. So we're going smaller to bigger, right? Which means we're going to divide. And we're going to divide by 10 to whatever power we, however many spaces we moved. So we moved 1, 2, 3 spaces, so 10 to the third power. In other words, divide it by 1,000, or chop off 3 of the zeros. That's what that really means. So this would be 20 hectograms. All right, so lastly, 20,000 kilometers equals how many centimeters? Notice here we're going from bigger to smaller. Okay, so here we're going from kilometers all the way to centimeters. Okay, so we're going to travel 1, 2, 3, 4, 5 levels basically. So notice we're going from bigger to smaller, so that means we're actually multiplying. So I'm not even going to be able to fit this in. I'm just going to move down here. So my answer is going to be the current number plus 5 more zeros. Okay, so in case you're curious, that's 2 billion centimeters. Okay. All right, so that should get you through the review. Okay, when you show up for the test, again, you don't bring your measurement sheet or anything like that. You're not going to be able to use that, but you should bring a calculator and show up ready to do geometry problems, but also measurement, area, formulas, all that good stuff.